side. Can you please raise your hand? 1, 2, 3, 4. So how many of you are done? Experience 20 already. Like, take another 5 minutes. Last 5 minutes. Two more minutes. Yes. Stop writing. Yeah, this way. Stop करो. Okay. Stop discussion. Every day. Even today is a 43, I think. Stop it. Okay. So, yeah, let us resume our discussion. Okay, so air pollution, that part we have been discussing. And what are the sources of air pollution? Right, so the sources of air pollution, that one is this, the stationary sources and the mobile sources. Right. So for the stationary sources, that industrial plant, power plant, those are things, and motor vehicles are the you know that automobile sectors is there. So here the thing is that how to reduce the emissions from the fossil fuel, right? So one easy way is that you reduce the uses of the fossil fuel or for power plant uses of the electricity. So lesser uses, therefore lesser emissions. But what are the techniques are there? But however, there is the optimum power generation is required there, or optimum usage for motor vehicles. So there are in 3 stages, not always all together, in hybrid or each one at one time it can be done. So first thing is that when you are using the fossil fuel, that what is the pre-combustion controls are possible, means that reduce the emission potential of the fuel itself, emission potential of the criteria pollutant during the combustion. Okay, so improve the that time the burning process. These are the things you can do, and the after emissions, then post combustion controls are there. Right. So let us go through a few techniques which I am going to discuss from this Gilbert Master's book. Give it a read there. And not going to discuss everything in details, but few things we may discuss in details. For that, you can refer to that Rao, C.S. Rao book, and I will tell you where to read and what to read. Anyway, I have slides. Anyway, I am going to share it here also. So this is a schematic diagram for a modern coal-fired plant. Right. So from here you can see what are the techniques that which are used to reduce the emission. The first thing is that this pulverizer, right? So pulverizer is that you can consider as a pre-combustion technique. These sulfur contents are there, right? Sulfur contents are there. So that can be physically or the chemically it can be taken out, right, from the coal itself. Okay. Second is that, not shown here, is that when it goes to the boiler or the furnace, so there you can use the fluidized bed combustion techniques, which can reduce this your sulfur content as well as this nitrogen content, okay, and NOx content actually, right? And then you can see the last one example here, a few examples from here, this flue gas, right, which is coming out. So here you can use electrostatic, this precipitator, this venturi scrubber, which can take care of the particulate matter and the SOx emission, okay, sulfur emission, right? There are a few other things that we are going to discuss later. Right, so here let us start from here. The pre-combustion control first, right? So pre-combustion control, one is what we said that the fuel switch, right? So use a low sulfur coal which can take care of this SO2 emission, or you can do that after pulverizing you can take care of this coal clean, right? So chemical or the physical treatment, either chemically or physically you can take out the sulfur content from there. This one is this fluidized bed combustion techniques. So what you do, you utilize these reactions with the limestone to take care of this emission of the SO2, so that what you are doing, you are going to convert that SO2 in this solid CaSO4, so that as a precipitate you can take it out. So you can see it here, this crushed coal and with the limestone, there is it's a schematic diagram, otherwise in these containers are there, it will go together there. And here there is a fluidized this combustion air that is from through this several nozzles are there at high speed against the gravity, it can go up there so that it can suspends this mixture, the coal and the limestone there. Okay, so that there are few advantages are here. So limestone and your coal, that is the usual that reactions are taking place. Fluidized here, that can mix this mixture very well. So uniformly it can mix there. Okay. It can, when it is there is a this when it is goes up like that, you can turbulence will be there. The turbulence actually takes care of the mixing, right? Okay. It can, when it's a mixture, the heat, this transfer will be much better to your fuel. So when the heat transfer is there, so your temperature requirement that also actually goes down there. As the temperature requirement goes down, then the NOx emission, it can take care of your NOx emission, because high temperature means that this NOx emission will be also higher, right? And here you can see the last one is coal with higher ash content can be burned since lower combustion temperature below the melting point of the ash. Okay. Anyway, this ash part as well as this so forth is actually taken care from at the bottom. This is another this technique, the integrated gasifications combined cycle, where what happens that in general you are actually enhancing the efficiency of the power plant. How? Right, you can see that any two power plants, right? If it is efficiencies are there, when you combined efficiency means that the waste heat, there will be, of course, by thermodynamically it's not possible to convert the full heat into the work. So there is a waste heat there. This waste heat can be utilized to run another cycle, and from there you can understand that for individually it will be always, the efficiency will be always higher than the individual's this efficiency, right? Efficiency means I am saying that the converting the work by heat, W by Q. So here you can see this where this gas turbine, this hot exhaust is there. So this is actually utilized it for to run another generator. So this is 1, this is 2. Okay. So this one is called the NOx emissions. Okay. So NOx emission, which is coming from, there is some nitrogenous part could be there in the fuel itself, as well as this combustion temperature that can be high. So this NOx will be emitted there, right? So there are few techniques are there. One thing is that first one is the low excess this air technique, where air is controlled at the minimum amount required for the complete combustions there. And the next one is that your low NOx burner technology, where this can be achieved in 2 stages. In the first stages, which will be air-starved environment, so there only the nitrogen that is released from there. And next stage, of course, for the burning, complete burning, you need the air there. However, that time it is deprived of the nitrogen, so that there only the other part that your combustion that is taking place. And you understand that air-starved, these techniques are that it is always cost to economical, right? So these are not always utilized there. And the last one is that which is the post-combustion technique, which is this your catalytic converter technique. So here in this flue gas, when it is coming out here, so you can inject ammonia, and this full thing that is run to catalytic bed. So catalytic bed, these are some these metals are there. One of them is this titanium. These metals are there. On top of it, this acts as a catalyst. Okay. So therefore, these reactions can take place very efficiently. And you can see that when you run on this thing, then there is NO that converts into your nitrogen. Okay. This one is the this Venturi scrubber, this what in general what is the scrubber is there, and these scrubbers are you can see that again that these reactions, these limestone reactions, that you take advantage of this limestone reactions, so that at the end you will get this CaSO3 or this CoSO4 also. This calcium sulfate. There is like this slurry that will be here. It will be deposited here, right? So here they say mostly it is used as this wet scrubber, right? Where this water is actually there. Sometimes there is this dry scrubbing that is also possible to use there, right? And you can use limestone or this lime also, where lime is expensive, and it could be like a throwaway or regenerative. Means that this slurry that is produced there, that you don't utilize that, so therefore it becomes a throwaway. If from there you can again try to recover this CS3 or this CO, so therefore it is called a regenerative process. So that plant also has to be there, so that you can recover and again utilize it. This is the particulate control, right? So in a power plant, so those are the criteria that polluters, if you remember that, these SOx, etc. is there, and with that, this particulate matter in the form of shoots, right? This carbonate, this particle that will come out there, and you know that what are these health hazards are there for that. So this one is a one common thing. It is called this cyclone collector, a physical process, physical process for particle collections are there. So here you can see that, right? This flue gas, it can come from there. This with containing the particulate matters, and you it comes with a very hot gas, right? So therefore, and you directed it in this cyclone, this collector. So what happens that when it goes there, there will be, first thing will be, there is a this rotation, and it will goes to these nozzles there. From there, it is a nozzles there, so there is a pressure build-up there, right? So pressure builds up there. However, because of this cyclonic, right? Cyclonic is there, so centrifugal these forces are there, so that the particles are like hitting to the wall, and they are losing their energy. Whatever this, because they are suspending whatever energies are there. Therefore, due to the gravity, they will be collected at the bottom, right? The gas, of course, that is always not that easy that they will lose their energy. Their pressure build-ups are there. They will come out, and this while coming out, that you can take it out from here, right? So, removal efficiency, that depends upon the size of particles and these cyclone, these dimensions are there. The efficiency, I haven't mentioned it here. That maybe like a in some other classes we can discuss the derivations of this efficiency later. Okay. So for this, the next one also is electrostatic precipitator, which is you can see this. Remember this schematic we have shown this modern this coal power plant. That is the first thing from where it is actually coming, right? So even this electrostatic precipitator was only things that was used, if you remember this schematic. So electrostatic precipitator, again a particulate matter, understand this physical process. So here you can see this is a very crude schematics are there. So there are these two plates are there. These two plates are two collector plates are there, right? So there are this series of several plates could be there. Other thing is this collector could be like a cylinder also, right? Two cylinder. The other thing, so which is a collector electrodes, you can say that, which are like a ground, which of course it is always easier to keep it grounded, which is a bigger electrodes are there. And in between, you can see that these wires are going on there, which are like a negatively charged electrodes are there. So it's a sharp electrodes are there. So when it's a sharp electrode and you have this big flat plates are there, so the electric field will be very high. because it's a converging there, right? It's converging to this. So therefore the electric field will be very high. If you see it from the top, say here, so it will be electric field lines. If you imagine, so you can see that it is a very high near to the electrodes, near to the wire. So that would be enough to create the breakdown, right? Create a breakdown the air, and means that that is which is called that this usual this typical this blue will coming. This is called this corona discharge, right? So what happens that when this corona discharge means that the air is broken down, so it will be creating the electrons and ion pairs. Normal electrons, but 3 electrons are there, but there will be many these electrons will be created there, and electrons like this are very mobile, right? So it will be having this tendency to attach to the particles. Either if it is a very high it's a atmospheric, of course, so there will be some recombinations will be there, but it has a tendency to just move and go and get absorbed there. So what happens that it sits on this, absorb on this particulate matter. Okay, so particulate matter, so those dust particles, they become negatively charged. As soon as they negatively charged, and you have your these electrodes are there which are grounded, so negatively charged is the grounded electrode, so they will just pass to the electrodes there. Okay, pass to the electrodes there, and pass to the electrodes means that it is actually forming a current, right? Whatever the small currents are there, that is forming the currents there, and when they will go to the electrodes there, and therefore this again they will give this excess electrons to the electrode, that particles that will lose their energy, and what happens that these dust particles are very fine particles, they will just deposit on this place. So layer by layer they will start depositing there, okay, on these electrodes there. When that of course it is start decreasing the efficiency, of course, there, right? This electric field generation, etc. So they can actually give it a little shape. So therefore this that is like it's already fully controlled there. So again these dust particles they are collected, that is come down, and this goes on there, right? So here as I said that you can see that there is this part is showing there. There is like a series of where it is going there. Okay, one by one. Yeah, it's like what is your you understand that the efficiency depends upon proportional to the collection, right? So means that area if you increasing means that there is a efficiency you are increasing there. So area increasing it what? Like you cannot have like a 2 plates which is like a big area, right? So what will happen, like a series of plates are there from where these gases containing dust particles that will go in there. Okay. So that efficiency, this is given by this Deutsch-Anderson equation. And you see that this is the total area of the collection plates, right? And this is called the Q is the volumetric flow rate of the gas through the precipitator, okay? And W is the effective drift velocity or the terminal speed. Alright, so what is the effective drift velocity or the terminal speed? This is here. Okay, so means that these dust particles, those are reaching the plates, right? Those are reaching the plates. Of course, the electric field is there, so it is accelerating, right? Accelerating. However, this one is you understand the environment is like in this atmosphere, and all dust particles are there. There would be like enough these collisions will be there. Otherwise, what would happen? It would be like a fully, if you give a like a bus covering fully this, right? So it will be like 100% efficiency, right? So here also very near to the 100% efficiency, and therefore it is accelerated, it is colliding, decelerated. So it will be reaching what is the terminal velocity, right? Two opposing forces are there. So therefore the drift velocity will be reaching there. So that drift velocity which is came into account here, right? So okay, W is the one, A is the your total area of the collection place, right? Means that both sides. If it is these plates are there, so therefore there is both sides that collection area is there. And Q is the volumetric flow rate of the gas through the precipitator. Means that which is like a coming in from here. This gas flow, you see that. So what is the volume of the gas per unit time that is going in here? Right. You need to know that. Oh. Are you in this class or you forgot this? Okay, I see. All right. So, you understand, right? I mean, that volumetric flow rate, you need to know that what is this area, right? From where it is going in, right? So, according to these problems, you can solve. Keep it in mind that for efficiency, what are the things are there. Okay, so here is very simple, some problems are given. You can see just to find out the efficiency of where everything is actually given. But depends upon the problems, that understanding is that what is the design of this. So here only you see that electrospecific is 6,000 meters square of collector plate area. Right, it is given that total area already given, sir, right? But sometimes that thing is that there are problems you can encounter which is not, I don't think in this book it is given there, we can discuss it later. Like that, what is the design of it, right? Sometimes it will be like circular plates are there, sometimes it's a series of plates are there. Then what should be actually the collector area? That you have to keep it in mind. Otherwise, the equation is set. There is no change in equation. So anyway, that you can check. Okay. So anyway, we will come to the class. Let us stop it here. You can meet tomorrow. So attendance, I will be taking it from here. What is missing at this?